Welcome, and thanks for coming to my presentation. My name is Joshua Krstic, and I work on the confidential space team at Google. In this talk, I will be discussing how to achieve secure collaboration across multiple cloud providers by utilizing confidential space and our attestation-based identity token. This is an important feature as many customers are adopting multi-cloud strategies and certainly have a number of cloud providers to choose from. We need to be able to bring sensitive data for joint collaboration from a diverse set of cloud environments. We shouldn't expect or require multiple parties to converge on one environment only. With this feature, we are able to support customers wherever they are and wherever they choose to store their data. To begin, let's start with a brief intro to confidential space. Confidential space is a special offering on Google Cloud. It is an extension to the existing confidential VM technology. Confidential space provides an isolated environment that enables your workload to operate on secrets in order to securely process sensitive data. This data may be proprietary ML models, PII, health data, or anything else. To accomplish the goal of workload isolation, confidential space is made up of several components. It starts with the workload. The workload is a containerized image provided by the customer. The workload is the entity looking for authorization in order to access the protected resource. In order to obtain this authorization, the workload interacts with the confidential space image. The confidential space image is a VM image based on Google's container-optimized OS. Confidential space modifies the base image to provide increased isolation. This includes disabling SSH access and other mechanisms. The confidential space image collects an attestation report from the VTPM and sends it to the Google Attestation Service to be converted into a more usable form. The Google Attestation Service takes this raw attestation evidence, parses it, evaluates it, and produces an OpenID Connect token. This token is signed by Google and handed back to the confidential space image. The workload is then able to access this attestation token to exchange with an IAM system to gain access to the protected resource. Let's get into the demo. Before starting, I wanted to list some caveats. This demo was accomplished in a test environment, but uses a real confidential space workload. The claims and tokens used are emulated to behave just like real tokens. Some details presented in this demo are subject to change when the feature becomes generally available. As I mentioned at the beginning, we recognize that customers and partners have their data stored across various cloud providers. At the same time, these entities sometimes need to be able to collaborate and jointly process data. This should not require massive data migrations. Customers should be able to perform this type of secure, multi-party collaboration across entities with data in Google Cloud, AWS, Azure, other CSPs, and even on-prem. In this fictional scenario, I'll demonstrate how one organization can utilize Google Cloud confidential space to securely process data located in AWS owned by an entirely different organization and protected by a key also stored in AWS. MealCorp is a company that specializes in custom meal preparation. It has a proprietary system that, when presented with employee meal preference data, can automatically order meals for each employee. Corporation Corp is contracting MealCorp to feed its hungry employees. Corporation Corp is a steward of privacy and recognizes that this preference information is PII. It requests MealCorp to come up with a solution to provide its services without being given access to the meal preference data directly. Additionally, Corporation Corp data exists only in AWS, whereas MealCorp primarily utilizes Google Cloud. This demo shows MealCorp's use of confidential space in order to securely process Corporation Corp's data, which is stored in AWS. Before continuing, I wanted to reiterate that AWS is just an example. Data can be stored in any cloud provider and still be functional with Google Cloud's confidential space. There is some setup required to have a functioning confidential space workload for this contract. The first 3 steps would all be completed by Corporation Corp, the owner of the sensitive data. First, we will create a symmetric encryption-decryption key in AWS. This key will be used to encrypt and decrypt the sensitive meal preference data. To secure the key we made, we will then write policy to only release it to secure, trusted workloads running in a trusted execution environment. Next, we will upload our encrypted sensitive data to an S3 storage bucket. Finally, MealCorp, with some information from Corporation Corp, will run their workload to be able to order meals for the hungry employees. Let's jump into step 1. Before creating the key, we must complete some setup to integrate with confidential space. The first step is to create an identity provider. This identity provider is the Google Attestation Service. We select the service just by entering its URL. For this demo, we use the test attestation service URL. The real public URL is listed on the screen for your reference. After setting the provider URL, we must select a custom audience that will be used. In our example, Corporation Corp will select Meal Corp's domain https://meal.corp as their custom audience. Now that we have an identity provider, we need to create a role. This role will be assumed by Meal Corp's workload to gain access to our decryption key and S3 bucket data. Be sure to select the identity provider and custom audience that we just made. And finally, we create our key. At the bottom, we need to give access to the role that we just made. And done. Now that we have our decryption key in AWS, let's write the policy needed to release it to trusted workloads. To maintain the security of the key, Corporation Corp needs to write this policy. Seen at the top of our condition block is a check for the custom audience that we just set up. Below that, we are checking for confidential space, which is a special claim that the attestation service provides when it is confident the attested machine is running within a properly configured trusted execution environment. Finally, we are specifying that only the approved workload from Meal Corp should be able to access this key. Typically, this means that the owner of the sensitive data audited the workload. This code might be open sourced or co-written together or audited by a trusted third party. In a real-world scenario, you may specify multiple digests in your policy or even a container signature for increased flexibility for very frequently changing workloads. One very important check not seen here is the issuer check or other standard OIDC claim checks. We need to be sure that the tokens used to assume this role are indeed from the Google Attestation Service. In AWS IAM, the issuer check is handled by the web provider and audience setup we did in the previous step. If the token comes with an invalid issuer or invalid audience, AWS will automatically reject the role assumption request. Now that we have our key and we've configured it to be released to our workload, let's upload the sensitive data. Here is the data in a simple S3 bucket. And similar to our key, we must configure the bucket to be accessible to the role that we just set up. After all that set up, Meal Corp's operator is almost ready to run their workload in order to feed our hungry employees. The final step for Meal Corp is to modify their workload to interact with confidential space primitives. First, we must set up a client to communicate with confidential space. Confidential space collects the attestation data and handles the protocol with the Google Attestation Service. The client is a simple HTTP client over a Unix domain socket. We set up a request to the custom token endpoint with custom parameters. For this example, the important parameters are the token type, which is AWS, and the audience, which is Meal Corp's URL, https://meal.corp. We then complete the request to the confidential space image. After collecting the evidence and talking to the attestation service, the image returns to us a fully signed OpenID Connect token. The token does not need to be parsed by the workload. It only needs to be handed to the AWS IAM during the credential exchange. To exchange the token with AWS, we create what's called a Web Identity Role Provider. This role provider is configured to read a token from a file on disk. With the provider created, you can specify the credentials for your AWS calls to use this role instead of the default AWS credentials. By specifying the ARN of the role we just made, the role provider will interact with the policy that we wrote during our setup. With these simple changes, your containerized workload is now ready to be deployed to confidential space. I have a video demo here that I will narrate over. First, we'll create a new VM and name it something fitting. Once we have our name, we'll scroll down and be sure to enable confidential VM. Again, we are built directly on top of confidential VM. We'll then head over and update our boot disk to be the confidential space boot disk. The version you see will change as we release new features. Scroll down and allow all access to cloud APIs. And the extra settings, we need to go into security and turn on secure boot. This is a required setting for confidential space. And finally, in management, we're going to add some metadata. The first metadata I'm adding here is how we configure confidential space to use your containerized workload. This is my test AWS containerized workload. And the second one redirects the container's output to cloud logging. This is optional, but I'm using it to show the output of the workload. Hit save. We're going to fast forward through the setup. Usually takes about 2 to 3 minutes. Very fast. And now that our workload has run, we can see that the token that was handed to us from confidential space. Again, you don't normally need to parse this token. I'm parsing it just to show you. We can see the meal.corp audience that we set up, and our very special AWS claims that contain confidential space and our workload digest. We can then see that we were able to download the data from S3, decrypt it, and of course, finally, we can feed our hungry employees. Hooray. In summary, customers need a way to collaborate with each other, and sometimes this collaboration includes very sensitive data like PII or meal preference data. Trust and execution environments like Google Cloud's confidential space enable such secure multi-party collaboration. In addition, collaborators' data may be located across different cloud providers. This should not hamper their ability to cooperate with other entities. In this presentation, we demonstrated how Google Cloud's confidential space can access data and keys located across multiple cloud service providers. As we showed, it is now possible for collaborators to use Google Cloud as their TEE while storing their data or keys in any other cloud provider. Before we go, the demo showed a requirement to specify an AWS token type. Our standard token is a generic and RAT-spec conforming token, which works great on Google Cloud. This format is not fully supported by all cloud service providers. We believe that attestation could be a true common language, but we need to make sure we all speak the same dialect. We are hopeful and excited to see other cloud providers adopt a standardized generic protocol like RATs to make this process simpler for our customers in the future. Thank you for listening. I hope you found it informative. If you would like to see the full workload used, we are currently working on publishing a comprehensive code lab to cover this use case. We expect this to be available soon. For more information, please head over to the following links on screen. Thanks again.